All right, we are ready to cover a pretty major topic next, and that topic is strings. We're going to cover a whole bunch of stuff here, things that are obviously in the computer science curriculum, but we're also going to go off the beaten path a bit and talk about some things that go on behind the scenes that they kind of overlook, and we're also going to grab a couple things from future units that I think we can apply now. And so there's just a lot that we're going to talk about, both programming wise and conceptually. So this is going to be a long one. So strap in, buckle up, whatever. Got a lot to cover. So we are going to be talking about strings, and so I've created a new class here. You'll notice we're not talking about. Well, actually, we are talking about, but we're not building any classes today. We're just we want our main method. And that's it. And so we've already discussed strings and we know a little about them, but we've glossed over a bunch of the things in Unit 1 because we didn't have the information necessary to really have a good conversation with them yet. And so we're going to try to hammer out some of those things to begin with. So let's just start with the basics again, things that we've already seen. So if I want to create a new string, I can. I'm just going to call this, I don't know what we're going to do, names, name1 equals, and then I need a name to work with. And so what we've seen so far is I can declare strings this way. This is called a string literal. It is literally a string. It is that value of a string. It's not an object being represented by a variable. It is literally that value of that string, in this case, Alan. And so one thing that we should stop and be able to do is think about, well, you know what? Actually, that doesn't make a lot of sense based on what we know. We were just talking about the fact that strings are objects. They are not primitive types. There's not a defined amount of memory that's allocated to them. And so if that's the case, then I know that there's a certain way that I should define all my objects. And the way that I should define all my objects, of course, is with a constructor. Well, there's no constructor here, which is strange. And so the question is, well, should there be? And how is this different? Well, what's worth noting, number one, is that strings are objects, but they're a very special object. In fact, here, let me pull up. I'm going to search for Java strings. They're very special objects because they are inherent in Java. In fact, they're part of this java.lang package, which just includes a whole bunch of things that we'll talk about later as well, that are necessary and kind of essential to the Java language. That's what java.lang is, Java language. These are all things necessary to Java language. We'll talk about the math class that's in there. Wrapper classes are in there. String buffers, which gets referenced down here. Like all those things are in this java.lang. And so what we're looking at right now is the API. So if you remember what an API is, it's an application program interface. And what that means is that it just kind of houses all the information about a given language or subset of the language. In this case, is the string class. And so I can look in here and I can see there are so many methods. I scrolled past them, but a whole bunch of different constructors. And then there's more information down here as well. And so there's a ton going on in this string class. The point being is that's a very special one for Java, and that's why it has some special kind of abilities that we're going to talk about in a bit. So I can define a new string using a string literal, special to the string class. Okay, I can also though define a new string exactly the way that we would expect to in Java using objects, and that would be by using a constructor. So new, and then a string constructor, and then what I would pass into it is going to be the string literal that I'm going to use, in this case, Alan again. So that is fine. Additionally, I can create a string, name3 in this case, and then I can do that using a previously named variable like so. All All right. So these are all different ways I can create strings. Nothing should be too shocking here, besides maybe the first one and the fact that it works the way that it does. Now, you'll notice I stopped here. If I go back and I pull this up one more time, please. Thank you. We'll notice is that there are actually a whole bunch of other constructors in here, taking in some things that we're not really going to talk about yet. But it's worth noting that there's only a subset of these things that we care about right now because we're taking the Computer Science A course. So in fact, let me pull that up. So there's this thing called the Java Quick Reference. Here it is, Java Quick Reference, which is a subset of the API for Java. In fact, you can make the argument that the Java Quick Reference is kind of like its own API. It's describing these different functions that exist within Java that you are going to be able to use. This list is straight from the College Board and is straight from the assessment, the AP assessment when you take it. You will get a copy of the Java Quick Reference because in theory, what really they want you to be able to do is not have to go into the assessment memorizing anything, but rather being able to understand how to apply some things. So what we can see here is that there's actually a subset of string methods that we can use. Here is the one that we just talked about. This is our constructor, which creates a string with some string input. There's a whole bunch of other methods here that we're going to talk about in a second, but these are all in the Java Quick Reference, and so this will be something that you have accessible to you whenever you take the exam. And so we'll come back to that in a bit. So this is me creating some new strings. If I were to go and run this, nothing would happen. I'm not printing anything out, so whatever, no big deal. Okay. One thing that's worth noting while we're here, let me take my Java Quick Reference back out, and it's talking about the word immutable. So the word immutable means that it's unchangeable, and all of these methods don't actually change my string. So we can say that a string class, once we declare a new string, or rather initialize a new string, give a new string its value, it is immutable. It can't be changed. We can't change the actual value of it by using any of these methods. All these methods will return something, whether it's a portion of that string, or maybe it's a number related to the string, or maybe it's a Boolean if I'm comparing two strings, or whatever it is. It will return a value, but it doesn't actually change the string itself. The only way that I can change the string is by just actually overriding it. None of these methods will change any of my strings, and we'll see that kind of coming up. And it's important to know because you should expect that if I use any of these methods, nothing will actually happen to the string that I have. All right, cool. So here's another thing that we've kind of glossed over, but we've been using all along, and that is this idea of concatenation. So what concatenation means, and that's let's see, concatenation means the process of adding something. All right, so we're combining two things. To concatenate is to add something to something else. And so what that means is that I can add two strings together to combine to make one larger string. Also, don't think that I'm jumping away from this constructor stuff too quickly. We will be coming back because there's a lot more to say. I just need to get through some other things first. So concatenation of strings works the way that I think you might expect. So if I have another string, name 2, and set equal to string, what I can do to add these two names together is I can have another string, name 3, and set equal to, all right, so if I take name 1 plus and a space, and then plus, and then name 2, it's going to concatenate, and I shouldn't probably use the word while I'm defining it, but it's going to combine these strings together. The word is concatenate. It's going to concatenate these strings together. And so what that means is that it's actually just it's really going to smash them all together. So if I save this, and let's go and run it I have to do some navigating really quick. Desktop and Computer Science A and Unit 2. And then compile fun with strings. Oh, right, thank goodness. And then fun with strings. I realize this is all happening off screen. Oh, nothing happens because I didn't print it out. That was dumb. All right, let's print it out. All right, system.out.print line, and now we can print out name3. But it was nice to know that it compiled. Go back to my, yep, there it is. All right, run, or compile, and then run. Aha, so it can concatenated those strings together. It took name1, which was a variable reference to a string. It took my space, which is a string literal, and then it took my second name, which is again a reference to a string, and just combined them all together into one name for me. That is string concatenation. Now we can do this, though, a slightly different way. For example, let's say that we wanted to update name1. So I want to take name1, and I want to keep it how it is, but I want to add that space to it. Well, plus equals also allows me to concatenate. So if I do plus equals and then that space, and I take name1, and I plus equals, and then name2. What this will do is just like before, it'll start off with Alan, and then it'll take Alan plus the space, and then it'll take Alan and the space plus name2, which is Turing. And so this works exactly how we would probably expect it to. If I run this again, I should hopefully get no change. Oh, what did I do? Oh, I never actually. That's a good call. Thanks. If I run this again, nice. All right, concatenated just the way that I wanted it to. Okay, so I can use the plus equals operator as well to be able to add strings together. All right, so that's concatenation. Again, if you're coming from computer science principles and JavaScript, then we've probably already seen this, so it's nothing terribly exciting. Okay. The one thing that you might have also seen before, but has been glossed over, is this idea of escape characters. So there's these, and let me look up something really quick. So there's a whole bunch of characters in Java that are kind of hard to type, right? So for example, let's say that I want to have Alan Turing as my name, or maybe let's just take Alan. And actually, here's what I want to do. I don't want to create two variables, but I want his name to be Alan Turing, but I want it to be on two different lines. And so the question is, how might I do that? And so there's these things called escape characters. And what they do is they're a character that is following a, I always forget, I think this is a backslash, but this character. And what that means is that, for example, if I want to add a new line, I can put slash and then n, and Java will recognize this in the string class as being a new line. So if I throw this in here, so slash new line, you'll notice I'm saying slash just so I can avoid the fact that I don't know what it's called. And I print this out. Now I'll get Alan Turing on two lines. So you might be asking yourself, well, what other characters does this apply to? And the answer is there's a list. Here it is. I just pulled up the Java docs again because, of course, why would I not? So tabbing is one. Backspace is one. New line is one we just did. A carriage return, something that maybe isn't important. But these last three, honestly, I don't even know what a form feed in the text at this point. I don't know what that means. These last three are important, right? Because, so let's say that I am trying to put quotes into something. Whenever I put my double quotes in, what it thinks is I'm ending or beginning a new string. And so how can I do that? Well, the answer is I can put in these escape characters. So for example, let's say that I was like trying to mock him in some way and say, oh yeah, it's Alan Turing. And so what I could do is I could slash and then quotation marks and slash and then quotation marks. And if I save this, what I will get is Alan Turing in quotation marks then. Because if I did not have these, Java wouldn't know, oh, it thinks that I'm just ending my string here. It thinks that this was, okay, from one quotation mark to the next, that ends my string. You know, and oh, and here's another string, and there's this weird Turing thing in the middle. And so I have to use these slashes here as to show that the thing that follows the slash is actually something I need to be printed out in some way, shape, or form. So, yeah, the important ones are, if I ever want to have a confirmed, backslash, a double quote, a single quote, or a new line are the ones that we will most commonly use. Yes. So those are return characters, and they're just, or sorry, escape characters, and they just allow me to, use special types of things inside of my strings. Okay. Do we have the basics done? I think I have the basics done. Yep, I think we have the basics done. All right, so we talked about APIs, we talked about Java Quick Reference, we talked about Java.lang. Awesome. All right, let us pull up then this Java Quick Reference again, and we're going to start talking about some of these methods that are in here. How far in am I? I am undeterminable. Where's my stopwatch? 16 minutes. Okay. So these are the strings that we're going to talk about. String methods that we're going to talk about. Some of them are pretty obvious based on their names, but really the API should tell us everything that we need to know. So for example, let's look at length. The very first one is length. It returns an integer, which is what it says in the signature line here, and it says returns the number of characters in a string object. Well, that's pretty straightforward. Okay. So how about I do this then? Let's get rid of this. I don't care about that anymore. I don't care about this anymore. Okay. Oh, too much. Okay, so what the .length method does is returns for me the length of a string. So just like we called these methods before, using the dot operator, we will have the object that we're calling this upon. We will have dot, and then we'll have the method that we're calling, which in this case is length. All right. So name1.length, what we'll return is the length of that string. It doesn't change the string in any way, shape, or form. It's literally just going to return the length of that string. So in this case, if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I really hope I did that right. It's going to be embarrassing here if I didn't. Oh, thank goodness. All right. So if I return this, it's going to return the value of 11. Simple as that. Length of my string is 11. Okay. So that one's not too bad. Pretty straightforward. We will use that a whole bunch. You can already kind of imagine later on when we start talking about iteration, and if I want to do something like to each of the characters in a string, that we'd have to go up through the length. So you can imagine that being super useful for us later. Okay, next, substring. So the substring method returns a string, which is the substring. So it returns the substring beginning at index from and ending at index to -1. Index from and ending at index 2 minus 1. Oh, 2 minus 1. Okay. So what that means, and this is the one that I'm going to make the argument is a little bit confusing. So here's what it does. Well, actually, let's just look at an example and see what we get. So let me go back to, oh yeah, I want to throw this away. There it is. So let's say I look at the substring of name1 substring. Okay, so let's say I want to get the first, 4. I just want to get Alan. I want to get Alan out of name1. So the first 4 letters. So how do I do that? The answer is I can use substring. I need to give it a starting value, the first index, and ending value. So first thing it's worth noting is that the indices for a string start at 0, and then they go up until the very last letter will be the length of the string minus 1, since I start at 0. So what would make sense, I think, is that if I want to get Alan, that means I want to get the first 4 digits. So that's 0, 1, 2, and 3. A-L-A-N-N. 0, 1, 2, and 3. So what it would make sense to me, logically, is to ask it to print out the substring 0, comma, 3. And this should hopefully do what I want. So if I go and I run this, and I compile, and I run, and I did not get what I wanted. Why is that? Well, let's go make sure we read this exactly what it's saying. So it says, returns the substring beginning at the index from, which is what we wanted, so we did, and ending at index 2 minus 1. So what that means, and this is kind of the tricky thing, and you can make an argument whether or not this is intuitive, but if I want to get A, L, A, and N, what I'm actually going to ask it for is the index after the last character. I think of it kind of as like, hey, I want you to start here and then go up until this point and stop. Like that's going to be the starting point for my new string. So that means is that I actually want to go until 4. So I get A, L, A, and N, and then I stop at 4, at index 4. So if I save this and I run, I'll get exactly what I want. I got Alan. I got the first 4 characters. Okay, marvelous. So that's my substring method. It returns portions of my string depending on what I want. And there's actually a second substring method. That means that the substring method is overloaded. So here's another one here. You'll notice that this just takes in one integer value. And it's the exact same thing. So they get a little bit clever here. So instead of writing out what this does, they just say, oh yeah, to return substring from and then length. So what they're saying is that calling this on one integer is the same thing as saying, oh, going all the way up to the end of the string. So in other words, it's going to start at an index value and just give you the rest of the string. So in this case, let me say that I want to get the rest of Turing. So I don't want to get Alan, I just want to get Turing at this point. So what index is that? So it's 0, 1, 2, 3, and 4. So I want to start at 5. And this substring is the same thing as starting at 5 and then just going up to the end of the word. So if I want the rest of the word, I don't know how long it is, that's fine. I can Java compile and run, and it'll give me Turing. It'll give me the rest of it without that ending index. And so it is the exact same thing as, okay, how many characters are there? We said 11, right? So it's the exact same thing as calling 5, 11. It just saves me a little bit of time. Because, for example, what if I don't know how many characters there are? What if I'm taking input from the user and I don't know the length of the string? And so I can just use that. Now, to be fair, I do know the length of the string because I could just call name1.length. So using what we just learned about the length method, okay, so let's be clear about what we're doing here, is that I'm using a substring method, and inside of it, I'm starting at 5 and then going up until the length of the string, which is the rest of it then. So this also does the exact same thing. So now I've printed out the same word like 4 different ways. Cool, great, fantastic. Let us try some issues. What if I tell it instead that I want the substring, I don't know. So we said there's 11 characters. What if I go up to 12? You know, what if I go past what actually exists? I'm missing a parenthesis, aren't I? So the question is what happens here, and something interesting does happen. What is it? Okay, so what you'll notice is that I was able to compile. I did not get an error, which is important. That means that when Java tried to compile my program, it saw no issue with it, and the reason for that is because name1 is a string object. It doesn't necessarily know its length, and so the compiler doesn't catch the fact that I'm asking to go past the end of its value. Or past the end of the length of the string. And so what happens at runtime then, I get thrown this exception. Okay, this is the string index out of bounds exception. All right, this happens whenever, well, it tells me actually exactly right here. So I try to start at 5 and I try to go to 12, but the length of the string is only 11, which is no good. And so it throws this exception for me and tells me that was not helpful. So let's see if I try to put in a different weird value. Let's say if I go like up to -1, you know, am I going to get a out of bounds exception again? You might expect for it to, right? And I do. I mean, -1 doesn't really make any sense in this context, right? And so I can begin at 5 and a -1, but the length is 11. It's still saying, hey, that's garbage. All right, that makes sense. That's fair, Java. Good call. All right, that's the substring method. So how many have we done? We did length, we did substring, we did other substring. Now we're going to talk about index of. Index of takes in a string as well. That string that it takes in is going to tell us, it's going to return an integer, and it's going to tell us where the first occurrence of that string is in the string that we're calling this upon. And then returns -1 if it's not found. Okay. So what that means is this. So let's say I've got the string Alan Turing, which I do. And my question is, does the letter R come up in there? And we can look at it and say, obviously, well, yeah, it does. But here's what we can do. We can use the index of method. So again, the index of method is called on a string. So in this case, name1 dot, and then index of, and then it's going to take in a second argument for the string that we're looking for. So in this case, my question is, hey, does the letter R show up in there? And the answer is yes. So the question is, what is this going to return? Well, what it should return is the index of R in the string. So in this case, 0, 1, 2, 3, 4, 5, 6, 7. It's going to return the index of the letter R in the string. So if I save this and I compile and I run, and it tells me 7. It tells me the index of that. So not only can I test for letters, but what if I want to know, hey, is the ending ing in there? So I can test to see if the entire substring is in there as well. And in this case, it'll again tell me yes. It'll tell me yes, and it was at index 8. Now, what if we want to test to see if something's in there and it ends up not being in there? And I can do that as well. So let's say I'm curious to know if Alan Turing has the letter Z in his name. And so if I run this, and if I compile, and then I run, what I see is that it's going to return -1. So it'll always give me the index of the item that I'm looking for if it exists in the string. But if it's not in there at all, then it's just going to return -1, and that signifies that it's not in my string. All right, so that's index of. Round, what are we on? All right, didn't I count last time? 1, 2, 3, 4, 5. All right, equals. I'm gonna save that for last. That's our big one. This is the big fun one where we get to talk about some other stuff. So I'm gonna come back to it. All right, let's talk about compare to. So compare to, what it does, it returns an integer. Again, it compares. It takes in an initial string using the dot operator, and then it takes in another string, and it compares the two. So it returns a value that's less than 0 if this, so meaning the item that's being called upon, is less than the other one that's taking in. And then it returns 0 if this is equal to other, so if they're the same string, and then it returns a value greater than 0 if this is greater than other. When I say greater than or less than, what I'm talking about is alphabetically. So let us go and see what this looks like. So let's say I got Alan Turing still, which is at the beginning of the alphabet, and then I got a new string, name 2, and this string is obviously I don't know, Batman. That's a word that starts with the B. Okay. So I want to compare these then. So I'm going to use my compare to method. So I'm still using name1 dot compare to. and then name2. All right, so let us hypothesize here what's going to happen for a second. So it's going to compare these, and it's going to determine what these relative values are to each other. So name1 versus name2, which one comes first? Because obviously they're not the same. If I compare them and they are the same string, they'll just return 0. So it's going to return some type of number based off that. So let me go and run this. All right, and it returns -1. All right, well, okay, what does that mean? Well, that means that the string this is being called upon is before the string that is being put in as a parameter. Okay, so Alan Turing, because it starts with an A, comes before Batman. Let's try another one and see if this changes anything. So let's say if it's Catman. So if that's not what I want. What do I want? I want this. So if I try this again, so compile and then run, ooh, now I get -2. All right, so here's what it's doing. So it's comparing the first letters that are different from each other, in this case A and C. And then it's checking to see where they are relative to each other. Now C is 2 letters after A, as opposed to B, which is the first one that I tested, was just 1 letter after A. So that's why I got -1 the first time, and then I got -2 the second time. Obviously, if I change this to Datman, what I will get is -3 this time. All right, so let's try this. Let's see if we can extend this out. So what do you think is going to happen if we change this name to Alan Smurring? That's a pretty good name. So if I save these and now I compare again. Okay, so keep in mind. Actually, I'm not going to say. Don't keep anything in mind. Let's just see what happens. Ooh, I got 1 this time. Okay, so why 1? The answer is because up until so 1, 2, 3, 4, 5 indices in, they're exactly the same. So that's 0 up in that point. Then the first difference is this T and this S. And so how do I compare those? Well, T comes after S in the alphabet. So this word, Alan Turing, actually comes after now Alan Smurring alphabetically. And so what will happen is instead of returning a negative number this time, I will return a positive number. It's just comparing the first letters that are different, which in this case is T and S. So that probably begs one question that you might be thinking of. Well, what if one word is longer than the other? They're exactly the same up until this point. And then I just throw in this last letter here. What's going to happen? And the answer is, all right, gives me -1. So what's saying here is that alphabetically, we would put Alan Turing first because it ends first, and Alan Turing's would come after. I'm fairly confident this will always be -1. If there's no more characters here and there's one more here, then I'm just going to tell me -1, and then more +1 if they're flipped. Okay, so that is the compare to. Yeah, we can use these a lot if we're trying to alphabetize things or find the order of different items. Okay. Now the last one. How far are we now? Wow, 33 minutes. All right. Equals. Okay, equals is the big one. Equals is the big one because there's a lot going on here behind the scenes, and this is the part where now we're going to kind of dive off course and talk about some things that aren't actually in the computer science A curriculum. So, dot equals, what it does is it compares 2 strings together. If they are the same string, it returns true. If they are different strings, it returns false. Simple as that. Not a big deal. Okay. Now, if you have other programming experience, for example, if you took computer science principles with me and you know JavaScript, you know that, hey, we did use dot equals, but we used most of the time was this equals method, or not method, but equals operator that compared the 2 values. All right. So let's go ahead and rehash that just really fast. Go away. I want to get rid of all this. All right. So So if I just have integer x equals 5 and integer y equals 5, and then I system.out.print line, and then x equals, that's too many equals, y, what this is going to return is true. Should, same value, right? Yep, true. All right, if there are different values, there are 5 and 6, it would return false. No big deals. Equals just returns whether or not the two values are equivalent to each other. All right, now let's get into kind of the crazy world here. What if let's talk about ducks, yeah? I'm gonna make some ducks. Here's a duck. Oh, duck 1 equals new duck. I can't remember what my constructor was in the duck class. Was it just name, ID, and occupation? Great. So this is Alan. His ID is 0, and his occupation is computer scientist. All right, fantastic. I am then going to have duck number 2. Which equals a new duck, and guess what? It's going to be the exact same thing. His name is also Alan. His value is also 0, or his ID number is also 0, and he is also a computer scientist. All right, marvelous, fantastic. And then one more. Duck 3 will be equal to, and then let us just have him point at one of the other ducks. Duck 1. Perfect. All right. Let's do some comparing then. Let's use equals to compare some of these values. So let's system.out.print line. All right, I want to compare duck 1 with duck 2. Perfect. Let's do some copying and pasting here. Control C, bam, bam. How many do I want to do? Duck 1 with duck 2, obviously. Duck 1 with, actually, I just want to do the, I just want to do the 2. All right. I just want to compare duck 1 with duck 3. All right, so take a moment here and think about what you would expect to have happen. I'm comparing duck 1, which is Alan, ID number 0, computer scientist, with duck 2, Alan, 0, computer scientist. So the same value, same exact things, right? For all intents and purposes, like for us, they're same duck, right? And then duck 1 and duck 3, same duck as well. In fact, I just took duck, I created duck 3 from duck 1, right? So if I save this and I run it, I will get false and then true, which doesn't seem right, but it is. And so the question is, what's going on? And that's what we have to figure out. Okay, so let's see. Now we're really going to test my my OBS skills here. I would like to stop looking at my computer science things, and I would like to start looking at my drawing space. Move my keyboard out of the way. Okay, so we have to conceptualize this a little bit. So here's what's happening. Whenever we create objects, we have this stuff going on called memory, where we're storing things. There are two parts of memory that we're going to care about a lot in this class. The first one is called the stack, and the second one is called the heap. All right, so let's say we were writing our code and we just made an integer value x equals 0. Fantastic. Okay, super basic. It's a primitive. All primitives where they get stored is on the stack. So there's this space where we're just throwing things on here. When they get thrown in and when they get deleted later, they get deleted like in reverse order. When we talk about scope later, that'll also make more sense, but that's why it's called the stack. So this is true of all things. Like if I want to make a new, Boolean or whatever, y equals true, that also gets thrown on the stack. So what gets thrown on the stack are values that I know exactly how much space they're going to take up. So primitives. What that means is that whenever I create an object, though, I don't know how much space they're going to take up. And so what I need to do is I need to allocate space for them that's kind of like variable in nature. And where that gets done is on the heap. So, for example, what we're doing right now is we're creating new ducks. So if I create a duck, this is, we'll just call it duck A, so I have to write less, and it equals, and then new, and let's say our constructor actually just takes in a name instead of doing all the other stuff. Am I going to run out of space here? Alan. Okay, so here's what happens. Every variable that we create does get thrown on the stack. But if it's an object, where it really gets stored is on the heap. So that's kind of confusing, but let me go ahead and show you how. So whenever I use the new keyword, what that keyword is doing is it's saying that, hey, I need you to allocate some more space for me on the heap, please. So the new keyword is going to say, carve out this chunk of memory on the heap that I'm going to be using. What we're going to be storing here is Alan. All right. If we had like a default constructor here that like, okay, his ID number is 0, and then he's a computer scientist. Okay. So what gets stored on the stack though is a variable, and the value that it holds is a memory address. This is my memory address, right? And so what we refer to this as is what's called a pointer. So it's pointing at this location in the heap, saying, hey, yeah, I'm storing a value here, but if you really want to know what it is, go look at the heap. Those are all the actual attributes that it contains. Okay. So here's what happens, though. Am I going to go back to the right red? I don't know. Oh, shoot. So if I create a new duck B equals new. All right, so it's saying, hey, allocate some more space for me, please. Okay, done. New duck, and then we're also going to name him Alan as well. Crazy world. All right, so I also get Alan over here. His ID number is 0. He's also a computer scientist. Great. Over here on the stack, then, I have my new variable B equals, all right, so this is memory address 0, 0, 1. Okay. Okay, so then I got my pointer again, except this time it's pointing right here. All right, that's my second Alan. And so then the last thing I did in this code that we just wrote, essentially, was I made another duck, duck C, and this equals, and then we just set it equal to A. All right, so here's what that does then. C still gets created over in my stack. But what it does is says, hey, take the value from what A is and just give it to me. What is A? Well, it's memory address 0, 0. And so what that means is these are now pointing at the same thing. Both A and C are pointing at the same thing. So when we went to compare then, equals equals, so we said, so when we did A equals B, what's actually being compared is what's in the stack. And what's in the stack is memory locations. Memory location for A does not equal the memory location for B. Where's a different color here? The memory location for A does not match the same memory location for B. So these things are not equal to each other. False. On the other hand, when I compare A with C, these are the same memory location. This is true. I didn't give enough equals there, did I? Equals. Okay, so what the double equals operator does is it compares the values of the variables that they're holding in the stack. It doesn't touch the heap at all. Now, we have this dot equals method. Dot equals, so this dot equals, and then takes in some other value. This is one of two methods that we care about right now, which are inherent in every new object that we create. One was toString, and this is the other one now, dot equals. So if we were a good programmer, every time we write a new class, what we should do is and we don't know how to do this yet. This is unit 5. What we're going to do is what's called overriding the equals method. And so what we're going to do in this case, what we'd probably do for our duck class is we would say, hey, return true if the name is the same, the ID number is the same, and the occupation is the same as well. However, we haven't done that here. And so if we were to use the dot equals method in our duck class, that wouldn't work. But somebody has done that, and the answer would be our strings. So we're going to jump back then. All right, let's go back and talk about strings for a second. And okay, so I can't talk and do this at the same time. Okay, I need to get rid of my drawing space. Done. And back to my computer science space. All right. We're going to take everything we just learned about objects and then try to compare it to strings. And what we're going to find out, unfortunately, is that it doesn't all work the way that we think it's going to, but it's going to kind of. So we're now into the 46th minute, going strong, fantastic. Let's start over. Okay, so let us make some different strings that we want to work with here. So I got string number 1 here. This is name 1. This is Alan. Still great. String number 2, name 2 equals, how about this? Alan. Awesome, great name. String name 3. Name 3 is going to be new string, and then Alan. Okay. Let us do a whole handful of things here, and we're going to see what happens. And then we're going to take some guesses at what we think is going to happen. So I guess I said those in reverse. We're going to type this out. We're going to take some guesses at what we think are going to happen. We're going to look at what actually happens. Then we're going to figure out why we were wrong, essentially. Because based on, if you took everything you just learned about objects and applied it to here, it's not going to work out, unfortunately. But it's okay. All right, so I want to compare name 1 with name 2. All right. Marvelous. And then I want to, here, let me just copy and paste. I want to compare name 1 with name 3. Name 3, using my double equals. And then I'm going to compare, let's see, name 1 dot equals name 2, and then I'm going to system.out dot print line. Oh, I should have copied. I don't know what I'm thinking. Name 1 dot equals name 3. Name 3. Okay, I think that's everything I want. Just for organizational purposes. Okay. All right, so I'm going to compare using the double equals, name 1 and name 2, and then name 1 and name 3. Based on what we just learned, the equals operator, or double equals operator, compares things that are actually on the stack. Okay, and so it would look like that name 1 and name 2 are probably different objects. And so on the stack, they're going to be different values. So I'm thinking that this is probably going to be false, because these are going to be two different objects over in the heap. So they're going to be pointing at different things. So I'd imagine this is false. And for the same reason, I think name 1 and name 3, even though they're both containing Alan, are probably going to be different portions of the heap. And so these are going to be false as well. Dot equals, on the other hand, based on what we just said, hopefully should actually compare their values and see if they're the same. And so what I would hope would happen is that name1 dot equals name2 will return true, and name1 dot equals name3 should also return true. That's what I think I would like to have happen. All right, let's find out. So if I save, all right, true, false, true, true. Okay, so we were right some of the time. So I think we were right on this back end, the fact that dot equals is going to always like actually compare the values and tell me if they're the same, which it did. It said true for both of them. So that's great, fantastic. What probably threw us for a loop is the fact that we were assuming that these are both going to be false, but the first one was actually true. And the question is why? All right, so back to conceptual mode. So we're going to switch back to our nice little drawing of the stack and the heap. So I need to switch back to my drawing space and get rid of my computer science space. Marvelous. Okay, here we go. Different color. Okay. So let's look at the stack again. Got my stack. I probably didn't give myself enough room there. That's okay. And then I got my heap. All right, heap. Perfect. Okay. So what we did was we made a new string. We'll just call it A. It was equal to Alan. All right. So what happens is there's actually a special part of the heap. This is called the string pool. So what the string pool does is, because we use strings so often in Java, and because, you know, strings are kind of like one of our favorite things in Java, it has set up a special place for them, the string pool, in the heap. And so that is where almost all my strings are going to get stored. So in this case, when I create my first string, A equals, I'm going to, or what Java does is says, all right, let's go look at the string pool. This is where all my strings are stored. Do I have a string with Alan in it? And the answer is no, I do not. That's okay. I'm just going to go ahead and lop off a little chunk here. So this is Alan now. Perfect. Great. And we're going to say this is memory address 0, 0, 0. Again, so that's my memory address. So it's pointing at that. Fantastic. All right. Now, make another string. String B equals Alan. All right, so Java, in its effort to conserve space, says, all right, let's make my new variable in the stack. I'm going to go look at my string pool. Does the string Alan already exist? It does. It's right here. Awesome. Fantastic. I don't need to point anywhere else then. I'm just going to point at that same memory location. And the answer is, well, how could this possibly happen? What if, so if they're pointing at the same thing, what if, okay, so they're both pointing here, what if A changes its value? Well, there's a really important thing that we remember. So if you remember back to like minute 5 or something of our video, there's this word that came up. Strings are immutable. None of the methods that I can use will actually change the value of my string. And so what that means is that every time I create a new string, like if I were to change the value of A to something else, what it's going to do is just going to lop off a new portion of my string pool to store that. It doesn't actually change the value of that string. Alan stays how it is. And so anything that's pointing at that same string doesn't get changed. They're pointing at different things. If it's in the string pool, that's important. So that was all well and good. Made these two different strings. Nice job. String C is going to be equal to, and then we're going to use the new keyword. What does new do? New says, hey, would you please go section off a new portion of the heap for me where I can store something? And so in this case, we sectioned off a new portion, new string, Alan. Great. And so this in memory address is 010, which gets stored on the stack. Perfect. Okay, so this new string, string C, since I used the new keyword, it's saying, hey, I don't want to use the string pool, thank you. I am going to section off my new set of memory in the heap where I'm going to store Alan. And so the issue with that is now this kind of breaks down everything that we were hoping to have happen, is now because when I go to compare, C is not going to be the same string as A and B is, or are, am, yep. So what that means is, okay, so let's actually do our comparing then. So what were our comparisons that we did? We said, is A equal to B? And then is A equal to C? And so what these returned were, so is A equal to B? Yeah, they're pointing at the same thing. Yeah, even though they looked like we were creating new objects here, since we have this special thing called the string pool available to us, they're actually pointing at the same thing. So this is true. That was the unexpected thing. Now for the second part, when I compare with C, since I allocated my new location memory to it, they are pointing at different things, so this will be false. Now, here's the thing, and that you might actually then think, oh, okay, we were just wasting a whole bunch of our time here, but oh well, I don't care. I think this is interesting and it's useful. If I use the dot equals method, it alleviates all my problems. So if I take A dot equals, I am no longer comparing what's in the stack and comparing these memory addresses. What I'm comparing is instead the actual values of A and B, of which A and B do contain the same string. So this will be true. I just realized I switched colors there. That's okay. And then A dot equals C will also be true because they contain the same value. And so equals equals, again, so this is a great summary, equals equals will always compare what's actually on the stack. The fact that the string pool exists kind of messes with us here because it makes things equivalent to each other when we're not expecting them to be. But however, if I ever declare new things using the new keyword, that'll actually create a new place in memory for them. What I should always do though, and this is why Computer Science A kind of glosses over it, is because if I just use dot equals all the time, I don't have to worry about this. And dot equals will always just compare the values of the actual strings themselves. So, oh nice, we're gonna get this in under an hour. How about that? So that was a lot about strings. This is not the final discussion on strings. We will talk about more things about strings later, but this is like the basics of it. The reason that this is so important, the reason that we're spending so much time about it, is because of how important strings are to just the Java language in general. Strings, are just, well, we can just use them for a lot of different things. I guess I shouldn't go into it more because we'll figure out later. But yeah, those are all the things. We talked about all the different methods. We talked about concatenation. We talked about, I don't know where my list went. We talked about constructors. We talked about immutability. And then, of course, we talked about the string pool. So that's everything that we need to know about strings for right now. Thank you for sticking with me for, almost an hour. Hopefully it was useful to you in some way, shape, or form.